Hi there, I'm Gaurav Kumar,
I'm Tanmay Gaurav.
And I am Aditya Varghese.
and we are here to present our final project of Mechanism Sessional on kinematic synthesis and simulation of an automated rear door mechanism for dumper trucks under the guidance of Dr. Anirvan DasGupta and Dr. Aghna Mukherjee. Now, to introduce you to our project, it's actually a dumper door actuation system where we use a linear actuator to lift our dumper bin. And the objective of this is to provide safe, reliable, and fully automatic rear door opening synchronized with bin tilt. So basically, we are eliminating the need of human intervention to open this bin. The key factors in this synthesis or design is the bin door angular relationship and the max door opening angle. This design is majorly used in dump trucks, tipper vehicles, or mine trucks. Now, proceeding to the next part of our synthesis, this is the synthesis model that we created in MotionGen to see beforehand how our finally synthesized or modeled mechanism will work. So, in the first part, we used an underbody actuator during our first iteration, and in the second iteration, we used a front mounted actuator. So, our consideration for an underbody actuator was because it provided a compact packaging initially, but during our synthesis, we found it introduced several issues. For example, it had a poor transmission angle in mid travel, approaching near singular values of around 20 degrees. And a very high actuator force is demanded because the lever arm was very small. All of these calculations are shown later in this presentation. Whereas in our final or the current configuration that we later synthesized, the actuator arm attached is at the front of the dumper, and it has a reduced stroke length of around 0.8 to 0.38 to 0.45 meters, and the mu is greater than 25 degrees. So this is kind of a more smoother and monotonic door opening as compared to the underbody actuator. Now there were a few trade-offs in this. In this underbody actuator, as I earlier told, there was poor force transmission, whereas in the front-mounted there was a safer kinematics, as there was no singularity crossing, and better torque generation about the door hinge. Now we'll discuss the procedure of our kinematic synthesis of this. So first of all, we had to choose few parameters. For example, here we are calling them performance targets. That's the input bin angular range to how much my bin will open, and with regard to that, how much do I want my bin door to open. So we took these values as 0 to 45 degrees and 0 to 70 degrees. So 45-degree input of the bin, the door must open by 70 degrees. And then we went on to initially dimensionizing our dumper bin and truck bed. So the dimensions here are written. For the link 1 it's 0.3959, for link 3 it's 0.7239, and link 4 it's 0.3867 meters. Now after that we used our loop closure equations to see if what we are trying to make here is a valid kinematic chain or not. Is it a valid mechanism or not? So here's the vector loop equation and here's the scalar loop equation. Both of these equations we solved, or you can say we tried them out in the MotionGen software for the values of omega 3, omega 4 and theta 2. Then we also had to do the dead center analysis. This will be discussed in detail later with my friend Aditya. So in the dead center analysis, we had to figure out if the mechanism gets into a dead lock somewhere or it works in some way that we don't want it to behave. After that analysis, we went on to the actuator stroke calculation, how much length the actuator must move to move the bin by 45 degrees, or per se the door by 70 degrees. And at the last, we calculated the actuator force for both of our synthesized mechanisms. And with the calculations, we found out that the force required for the mechanism where actuator is in front of the dumper bin is comparatively less than when it is in front of the under the dumper bin. So we went ahead to finally synthesize the mechanism where it is in front of the dumper bin. So now onwards, my friend Tanmay will talk and take care of things.
Hello, I'm Tanmay Gaurav. So now we will continue with the formulations. The dumper door automation system is a 4R mechanism with link BCG as a rigid body. The terminologies for the angular parameters are as follows. Theta is the bin tilt angle, phi is the gate open angle, alpha is the angle between link L1 and L2, and beta is the angle between L3 and horizontal. and with the subsequent relations, we determine the unknown parameters that we want to know. Using iterations of calculation to get the desired relative motion between tilt and opening of the door, the final dimensions that we got for this mechanism are as follows. We then made a simulation on the MotionGen software using the final dimensions that we got, and the results were satisfying. Relative motion between the tilt angle and opening of door was correctly working. The velocity of the actuator was set to 3 inches per second to get the graph. The first graph depicts the motion of the highlighted link BC, that is the part of the door, and the second graph is for the highlighted point B, that is the revolute between the door and the other link. So now Aditya will take you ahead.
Hi, I'm Aditya Varghese. This is the CAD that we made. This is Tata Prima truck, which we refer to, and it also has the linkage, the automatic door mechanism here, as you can see. So this is the hydraulic actuator. It is pivoted to the dumper as well as to the chassis, and this is the linkage. It is attached to the chassis as well as to the gate, and the gate, this is the second link. It is attached to the first link and also to the dumper, and the dumper, it is attached to the chassis via this point, in this point. So this is a 4R linkage, as you can see. This is the first link, this is the second, and the dumper is the third, and your chassis is your fourth. So while making the design, we encountered a few problems in this. First, as you can see, we encountered that there was a dead center between the minimum position and the maximum position of the dumper. So while designing, we had to keep this in mind that the 4R linkage is non-Grashofian, as it will prevent the dumper cover to flip and to move in the opposite direction. So as you can see, in our first iteration, we had a dead center here, as you can see. And in our final iteration, we changed that by changing the length of the first link and by shifting the position of the revolute joint with the chassis towards right. So first of all, we need to make sure that the mechanism is non-Grashofian, and to be specific, there is no dead center between the minimum and the maximum position of the dumper. So as you can see, the mechanism, there is no dead center between the minimum and the maximum position. You can also see the linear hydraulic actuator here. So with this, we conclude our presentation. Thank you for watching this video.